first one we're going to look at is 4 terms factored by grouping. Okay. And of course, when you're factoring, you should always think, is everything on one side in standard form? And can I factor anything out? Right? Those are always your first couple steps. So everything's on one side, 3, 2, 1, 0, standard form. There's nothing I can factor out, so I can go ahead and factor. Okay? So factor by grouping. And I'll kind of write the notes over here. In your notes, you'll probably want to reword it so you understand. But in my words, my notes would look something like this. Group the first 2 terms together and group the last 2 terms. And what do I mean by that? That means group the first 2 terms together, like that. Group the last 2 terms together, like that. So I'm forming 2 groups. So you're just putting parentheses around the first 2 terms, parentheses around the last 2 terms. Okay. The second step then is to factor each group. So what does that mean? That means I look at the first group and I think, what can I factor out? X cubed and 2x squared. What can I factor out of both terms? An x squared. Yep. So if I factor out an x squared, what would be left? An x and a 2. And then I look at the second group, and what can I factor out of 5x and 10? 5. A 5. Okay. So then your last step is factor out the common binomial. Okay. So what you should notice when you did this is you have 2 terms, and each term has an x plus 2 in it. Okay? So just like up here, I had 2 terms and I said, oh, I can factor out a 5, and I took out a 5 and then wrote what's left. You can do that exact same thing, but instead of factoring out a number or a variable, you're factoring out a binomial. So if I factor out the binomial x plus 2, I think, okay, if that's gone, what's left in my first term? X squared. What's left in my second term? 5. Now it's factored. Okay. So this was the work I needed to do in order to solve it, because factoring was not the solution. Factoring was the work I needed to do, and now I can solve it, right? I need to find, this is a 3rd degree polynomial, so I need to find 3 roots. Right? What does x equal to make this equal 0? There should be 3 x values that I can sub in that this is going to equal 0. So I go down here and I go back to my 0 product property, and that says wherever I'm multiplying, one of those has to equal 0, and for the whole thing to be 0. So this one's easy. What plus 2 gives me 0? Negative 2. Okay. This one's a little bit trickier because it's x squared. So I would set that equal to 0 and solve, right? What x value would make this equal 0? Use my algebra skills, subtract 5. So x squared equals negative 5. How do I get rid of a squared? Square root both sides. What do I do when I have a negative underneath the square root?
Oh, you can't do that.
Take out an I. Take out an I. So x would equal plus or minus I root 5. There's 2 roots. Positive I root 5, negative I root 5. And here's my third, negative 2. Look at the next example. So again, is everything on one side? Yes. Is there anything I can factor out of every single term? A 2 and an x. Very good. So if I take out a 2x, then I have this. Okay. So I know one answer right now, because whenever x is a factor, what's a root? 0. Whenever x is a factor, 0 is a root. So I know one answer is 0. But I need to factor by grouping here 4 terms. So I factor by grouping to find the other 3 roots. So what's my first step? Factor by grouping.
Cube plus 6.
Group the first two terms together.
Do you put 2x in front of it?
Yep. Group the second two terms together. When I get all done, I'll put the 2x in front.
Okay.
You can just leave it hanging out there right now and just know that's going to carry down. What's the second step? Factor each group. So what can I take out of x cubed and 6x squared?
X squared.
What can I take out of both terms here? Oops, I made a mistake, didn't I? That should be a 3.
You didn't take it out.
2
9.
times 3 is 6. I forgot to factor out a 2. So that should be a 3. So that should be a 3. There we go.
There you go, 9.
Okay, now think about this. You have to use a little bit of your brain a little bit because you should know factor by grouping. I have to get this common binomial. So I'm going to factor something out. So what's left is x plus 3. So I'm not only going to factor out a 9, what else am I going to factor out? A negative, because I need both of those to be positive to match. So I'm not just going to take out a 9, I'm going to take out a negative 9. So then I get a common binomial. Okay, sometimes you kind of have to see how are they going to match. So sometimes you have to take out a negative for that to happen. And then my last step is to do what? What can I factor out of both terms? X plus 3.
Oh, yeah.
So if I take out an x plus 3, what's left in the first term? Okay. Now, I still have the 2x, don't forget that. I should be able to take this factored form and find all 4 of my roots. 2 of them are pretty easy to see. What are they? 0 and... Okay, now I need to solve this one and find 2 more. Some of you might be able to see that. You're going to add 9 square root both sides, plus or minus square root of 3. If you can't see that, you got to go ahead and use your algebra. So then I would square root and I'd get plus or minus 3. So what happens is something has multiplicity. What root has multiplicity? The negative 3 happens twice. See that? So negative 3 would have multiplicity of 2. And you could either write it like that or leave it like this. That's fine. But just recognize if a root happens twice, it has multiplicity. Don't forget about that. So let's do one more. If you turn to the back, number 11, you should recognize 4 terms. That's also going to be a factor by grouping. But on this one, what's going to be my first step? You're going to have to add the 16 to bring it to the left side. And then once I bring it to the left side, I look, okay, what can I factor out of every single term? A 2. Just a 2. This 16 doesn't have an x. So the only thing I can factor out is a 2. Okay. Now, 4 terms. It's in standard form. So what's my first step in factor by grouping? Group the first 2 terms together. Group the second 2 terms together. What's the second step? Factor each group. What can I take out of x cubed and 4x squared? X squared. Very good. Whoops, 4. What can I take out of 2x and 8?
2.
And hopefully I created a common binomial, right? If that doesn't happen, you can't factor by grouping. So either you did something wrong or it's not factorable by grouping, okay? So you should have a common binomial that I can factor out, and once that's factored out, what's left?
X, or yeah.
Okay? Now I need to find, this is a cubic polynomial, so I need to find all 3 roots. So if this says equal to 0, and this is where I'm multiplying, here's the easy one. What plus 4 would give me 0? solve this one, I would subtract 2, square root both sides, so I get plus or minus I root 2. So there's my 3 roots, -4 and plus or minus I root 2.
What about, do we get rid of the thing that was outside?
Okay, so when you're factoring with 2 terms, right, let's review the first one we learned back in the last chapter, okay? When I was factoring with 2 terms in the last chapter, we called it difference of squares, right? Difference of squares. What does that mean? That means if I was subtracting 2 perfect squares, I could factor. For example, if I had x squared minus 4, I could factor that into x plus 2, x minus 2. If I had x squared minus 81, that would factor into x plus 9, x minus 9. If I had 16x squared minus 9, I could factor that into 4x plus 3, 4x minus 3. Get the pattern? We went over that last chapter, but here's a refresher. So then if I get something like this, x squared minus y squared, well, how can I factor that? X plus y, x minus y. Right? That's my pattern. My pattern, my rule would be if I had something squared and another number squared, I could factor that into a plus b, a minus b. That would be my formula for difference of squares. Okay. So, if I'm adding or subtracting cubes, not squareds, cubes, I also have a formula. Okay, here's the one for if I'm doing sum of cubes, because sum means adding. Here's the formula if I'm doing difference of cubes, because difference means subtraction. So in order to continue on with this, first of all, we'd probably have to review together what are our cubes, right? So 1 cubed would be what? 1. 2 cubed would be 8. 3 cubed would be
27.
4 cubed would be 5 cubed would be
125.
6 cubed,
Bro, I don't know. why do we have to know this?
216, 7 cubed,
That's too far.
49.
I'm drawing the
3
line.
what?
You're putting it in the calculator.
8 cubed would
I
be
do
what?
not care.
512. 9 cubed,
729.
okay, and hopefully you know 10 cubes is
I'm
1,000.
really happy for you.
Most of these won't go past 5 or 6, right? Because even past 5, I don't know those in my head. I only know up to 5, okay, and 10. So when you see 2 terms, right, how do you know you're doing by sum and difference of cubes, right? Because that's going to be the hard part. When all of these are together on the quiz and I say factor and solve, how do you know what method to use? Well, if it's 4 terms, right, if there's 4 terms, you should know factor by grouping. If there's 2 terms, we should think, okay, are there squareds or are they cubes? And if they're cubes, I'm going to use one of these formulas. If it's squareds, I'm going to probably factor by difference of squareds. You don't have to memorize these formulas, right? Not yet. Pre-calc you will. Okay, so let's think. You're going to use this formula just like you would like a quadratic formula. What's my A? What's my B? I'm going to plug those in and solve. Okay? So how do I find my A and B? Well, I have to think. What cubed would have gotten me x cubed? X. What cubed would have given me 64? 4.
4.
So x is my A and 4 is my B. So when I go up here, sum, because I'm adding, right? My x is going to go in for every single A, And my 4 is going to go in for every single b. So then I simplify, I get what? X plus 4, x squared minus 4x plus 16.
What is the point of that? What question?
Now it's factored. Once you find the a and b and sub them in for a and b, you then get the factored form. That's factored. There's nothing else you can factor. But you still need to solve it, right? I still need to solve because if this is a cubic, right, third degree polynomial, I need 3 roots. One of them's pretty easy. What is it? -4. I know x is going to equal -4 right here because -4 plus 4 is 0. But this is a quadratic, right? There's 2 ways I know how to solve a quadratic, factoring or quadratic formula. The bad news with this is that this will never be factorable. When you're doing sum and difference of cubes, you will always have to use quadratic formula. Always.
That's annoying.
Always. Okay? So, quadratic formula. Here's my A, there's my B, there's my C, right? Here we go. Negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times
Do
A.
you actually have to do that?
Yep, you're going to have to do quadratic formula. So what's that? 4 plus or minus square root of 16 minus 64, which is 4 plus or minus the square root of a negative 48 over 2. But I would take points off because that's not reduced. What's the first thing we should notice on reducing?
You can't have a negative in
You
the
can't
thing.
have a negative, so we should know that we're going to be taking out an I to make that positive. And then 48 breaks down. 48 is 4 and 12, and 12 is 4 and 3. There's 2 4s, take one out.
What the? You didn't factor it all the way out though. You have to do 2.
You could break it down 2 and 2 and 2 and 2, but as soon as you get 2 of something, circle it. Less work. Right? As soon as you get 2 of something, circle it. Be done. Don't break it down. Right? It'll save you some time on these problems. So then I get 4 plus or minus 4I root 3 over 2. But am I done? No. One more step, right?
But wait, there's more.
One more step because 2 goes into both of those. So I would get 2 plus or minus 2I root 3. Right? So if you didn't learn quadratic formula last chapter, here it is again. It's not going to go away. The only chapter we will not have this is our chapter on statistics. So do I have 3 roots? Yes. X is -4, 2 plus 2I root 3, and 2 minus 2I root 3. Okay. When you're doing subtraction, when you're finding your A and B, you're not going to think of that subtraction as part of your B because your formula will already have that negative in there. So you're just going to look at the x cubed and the 1,000. You're going to ignore that subtraction. So what cubed gives me x cubed? What cubed gives me 1,000? X and 10. So when I look at my formula, right, for difference of cubes, you're going to be putting x in for all of the a's, and you're going to be putting 10 in for all of the b's, right? And then plug it in. So I'd get x minus 10, x squared plus 10x plus 100, which that is factored. It's factored. I'm done. That's the work I needed to do. That's the work I needed to do in order to then solve it. It's factored, but I still need to solve it. So what's the easy one? What do I know? X equals 10. Good. Right? That's the easy one. What minus 10 is 10? Or what minus 10 is 0? This, again, will never be factorable. You have to use quadratic formula. So here's my A, here's my B, here's my C. Let's plug it in, right? -10 plus or minus square root B squared minus 4 times A times C all over 2A. which is negative 10 plus or minus square root of 100 minus 400 all over 2, which is negative 10 plus or minus square root of negative 300 over 2. But I need to reduce that. That's not done. I got to reduce it. So what do I know? I know that if I have a negative, what's going to come out? An I. Good. So I know there's going to be an I out there. What else? Well, 300 is 103, and 100 is 10 and 10. There's two 10s. Take one out. So I get negative 10 plus or minus 10 I root 3 over 2. Am I done? One more step. I need to take 10 over 2 and 10 over 2, which is 5. Negative 5 plus or minus 5I root 3. There's 2 roots. There's my third, and now I'm done. The last factoring method that I'm going to show you today it's not a new one. It's just recognizing that if you have a quadratic form, like 420, you can factor that the same way as if you had 210, right? So think, how would I factor this quadratic? What would I multiply equals 2 but add equals 3? How would I factor that? You would say x plus 2, x plus 1, and then you would solve x is negative 2, x is negative 1, okay? So if you have 210 or if you have 420, you can factor both of those the same way. The only difference would be these are going to be squareds when you break apart the FOIL. So I would say, okay, what do I multiply equals 72, but add equals negative 1? Negative 9 and 8. Okay, so what's different is this going to be an x squared. X squared minus 9, x squared plus 8. Okay, you're going to break apart that FOIL with the squareds now. And then you just solve both. You don't have to use quadratic formula, that's the good news. You just solve both of them. So set x squared minus 9 equal to 0. Take x squared plus 8 and set it equal to 0 and use my algebra to solve. So I would add 9 and then square root both sides. So I get plus or minus 3. There's 2 roots, but I need 2 more. So again, subtract 8. Square root both sides, but I need to square root of negative 8. So I know an I is going to come out, and you should recognize, oh, there's 2 2's to come out. So it would be plus or minus 2I root 2. So there's this is a 4th degree polynomial, and I have 4 roots. So what am I going to do first on this one? You're going to have to add the 20 over. Very good. Okay, now factor. What do I multiply equals 20, but add equals 9? Very good. 5 and 4. So I would say x squared plus 5, x squared plus 4, right? And if this equals 0, I'm just going to set both parts equal to 0 and solve. So x squared plus 5 equals 0, or the x squared plus 4 could have equaled 0. Subtract 5, square root both sides. So I should recognize I need to take out an I. So plus or minus I root 5. Again, subtract 4. Square root both sides, take out an I, and I get 2. So there's my 4 roots. Last assignment, we always looked, can I factor something out first? So this kind of looks like a 4th degree, but if you look closer and get everything on one side, you should notice that I can take something out of every single term. What is that? An x squared. I can take 2 x's from every single one. Okay. So what happens is I end up with a quadratic. So this doesn't use any of the new methods that I learned today. This is one of the ones that we had on our last assignment. But the catch on this one is that this is not factorable. What do I multiply equals -10 but add equals 2? Not factorable. So how do I solve a quadratic? Quadratic formula. Yep. So that will be the other type that you'll have where you'll have to use the quadratic formula. Sum and difference of cubes will always use quadratic formula, and then sometimes you'll end up something like this that'll use the quadratic formula. So I'd have -2 plus or minus square root 2 squared minus 4 times 1 times -10 all over 2 times 1. -2 plus or minus 4 plus 40. -2 plus or minus square root of 44. But I can reduce. Right? Take out a, so I get -2 plus or minus 2 root 11. And then one more step, -1 plus or minus root 11. There's 2 roots. But here's the thing you need to know. If this is a 4th degree polynomial, how many roots should I have? 4. Where's my other 2? This gives me 2 roots, right? -1 plus or minus square root 11. What does this mean? There's 2 of them, multiplicity. So x equals 0 with a multiplicity of 2. So there's my